All right, the first thing we're going to talk about here is two intersecting secants here. They intersect at one point outside the circle, and you see they both go through and hit the circle 2 times each, so they're both called secants. The proportionality theorem that works is simplified down. It's just the outside times the whole is equal to the outside times the whole. Sorry for the bad handwriting. I'm kind of doing this on the fly. So outside would mean the portion from the point where the two secants intersect to the place it hits the circle. The whole would be the entire distance from the point that they intersect to the opposite side of the circle. So here I've got like the red secant with those two endpoints and the blue secant with those two endpoints. So outside times whole would be just this portion times the entire portion. Blue, same thing, just this small portion times the entire portion, the whole. So in these, you need to use the segment addition postulate, which says the whole thing is the outside piece plus the inside piece. So I chose an example to do from your PowerPoint, so you can check this out. This is slide 12, number 2. So we're going to follow that same thing. I'm just going to be saying outside times whole, right? Outside times whole equals outside times whole. So in this case, if I've got maybe this top secant is going to be my red one. So starts there, ends there. The outside of my red secant is just 3. It's just that piece. The whole red segment, though, is going to be 3 plus x plus 2. Which I know I can combine like terms here and just get x plus 5. So outside times whole is going to be 3 times x plus 5. That's my first secant. My second secant starts at the same place and ends down here. So outside times whole. Outside of this is just x plus 1. And then the whole is the entire piece from blue endpoint to blue endpoint is going to be x plus 1 outside plus the inside part, which is x minus 1. Now again, I want to combine like terms here. There's 2 x's and then there's plus 1 and a minus 1, so they're going to cancel out. So that's just 2x. Outside times whole. Great. Now, the part that I think people are getting tripped up on is the algebra portion of it. So when you have this set up, you're going to distribute the 3 in. So 3x plus 15 equals, here I've got 2x, and now I distribute it into those two, which is going to give me 2x squared plus 2x. Now, here's the part where we have to get to our algebra skills. I see this is an x value that's squared, this is a non-squared x value, and this is a constant. So I see those 3 things, so I know I have to get everything to one side and factor it. It technically doesn't matter which side I want to get it to, but it's much easier if you get the x squared term to be positive. It's positive on the right side, so I'm going to move everything to the right side, which would be subtract 15 over and subtract 3x. Again, combining like terms, I'm going to have the 2x squared minus x minus 15. Setting it equal to 0, I can now factor. So if you remember how to factor, it's setting it up into these 2 parentheses where the 2 first terms multiply to get the first term from your trinomial. The 2 second terms multiply to get the last term from your trinomial. And when you complete FOIL, the first times the outside, or sorry, the outsides multiplied and the insides multiplied together would need to add to get you that middle term. So I know it's going to be 2x and x. And my values here, you can make a table. This is really however you learned this originally, factoring. You could do that diamond method, but below it you put factors of 15, so like 1 and 15, 3 and 5, 5 and 3, 15 and 1. You can basically guess and check. It's different methods of doing that, but what you'd find is that this is going to be minus 3 and plus 5. Multiplies to get negative 15, multiplies to get 2x squared. And when I multiply 2x with negative 3, that's negative 6x. 5 and x is positive 5x. Those combine to get you negative x. So with those two binomials now, I know that either one of them has to be equal to 0, which means either x equals 3 to make this 0, or x equals negative 5 over 2, which is not possible, so x equals 3 is my solution. Hopefully that helped.